Okay, this is for geometry, a review of the Chapter 3 information that you're going to need to know for the test. The most important thing I can tell you is memorize the angle pairs that are formed when parallel lines are crossed by a transversal. Memorize the angle pairs. You need to know those. Just glancing at them, being able to find them on the paper, automatically know their names. Okay? Step 1, do that. They're in your notes. They're also right here. So, first, corresponding angles. So I've tried to put them in color. If you don't do color, if you're colorblind, 1 and 3 are corresponding angles because they're both to the left of the parallel line and above the transversal. They're in the same spot on the next shelf. Okay? 9 and 7 are corresponding angles. 4 and 6 are corresponding angles, and then these cute little dots here that don't have a number are corresponding angles. You can find corresponding angles because they're in the same spot on the next line over. Okay? They are always congruent, always. Alternate interior angles. Alternate interior angles are on the interior of the parallel lines. The parallel lines were the bread. This is inside where the peanut butter and jelly goes. Okay? They're alternate because they're on opposite sides of that transversal cutting through. A and B are alternate interior angles. D and C are alternate interior angles. They are always congruent. Alternate exterior angles are almost like alternate interior. They go on the opposite side of the transversal, but look, now they're not on the inside, they're on the exterior. So 8 and 10 are alternate exterior angles. 2 and 5 are alternate exterior angles. Okay? They are congruent. So, get those into your brain. There's one that's different. Same side interior angles. Interior means, see how they're between the parallel lines? But now they're on the same side of the transversal, not on opposite sides. So F and G are same side interior angles, and J and K are same side interior angles. This is the only pair that we have that we're going to deal with that are supplementary, not congruent. Okay? Do what you need to do. Make yourself some flashcards. Memorize those. Sample problem that you'll have to solve. Lines L and M are parallel. See the cute little arrow marks on there that tells me that they're parallel? What is the value of X? So I find here's an X right here. I analyze my picture and try to determine what kind of angles do I see when I look at that picture. Well, these are corresponding angles. They're both directly below their line and they are both on the right hand side of the transversal. So same place, one row down. Corresponding angles are always congruent. So that tells me what my equation looks like. This equals this. Boom. And then I do my math and I find that X equals 25. Find the relationship, write the equation, solve the equation. We also talked about the converse of all those theorems. So alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles. They say if the lines are parallel, then those angles are congruent or supplementary. The converse says if those lines are parallel, or if those angles are congruent or supplementary, it requires me to have parallel lines. So I can say I know the lines, it tells me the angles. I could also say I know the angles, it tells me the lines. If the angles are congruent or supplementary for same side interior, it proves parallel lines. And since we are in geometry, it's all about proof. So you're going to get a question that looks like this. Which of these lines are parallel given the information on the page? Okay? Well, first thing I noticed is I see 74 and I see 106, but they're not some of my pairs of angles. 106 would be corresponding, it would be here, right? This would be where I'd expect to see a corresponding angle that's congruent. Or I might see it over here for A as an alternate interior angle. Okay? Or what else could I have? Or alternate exterior angle. Or I could have 74 down here for an alternate exterior angle. Correct? So what I didn't have two angles that were automatically a pair, I could put in parts that I expect to see because these are supplementary angles. I hope you see that linear pair right there sideways. Those two angles added together have to equal 180. because they are a linear pair, and they do. So I'm looking now, and I'm saying, well, I could say that if I use this and this, I could say that angle M and angle L are parallel lines because of the alternate exterior angles theorem. Because I just chose a spot, I subtracted from my linear pair to get this number, and decided that this is congruent to this, and it's an alternate exterior angle. Please notice that that line S right here, it has nothing to do with what's going on. None of my angles are on line S. Nothing was involved in line S. I don't even have to worry about line S. So if I was trying to say that line S and T were parallel, I'd have to have some angles that were on S and T together. But my angles were all on line L and line M. So the ones that are parallel are line L and line M. So use the strategy of crossing out or covering up with your hand if you get a diagram that has extra information that doesn't involve your angles or your lines. When we finished with those, we moved on to the triangle. So that's what we just did last. The triangle sum theorem just says all the angles in a triangle add up to 180 degrees. And we proved that in class. So if I were trying to find x, I would just write x plus 46 plus 58 equals 180. And that's what I did. Then I combined some terms. Then I subtracted 104 and I found that, oh look, x equals 76. Yay! Okay. Now, we also learned an exterior angle theorem. The exterior angle says that the exterior angle, in this case y is an exterior angle because it extends beyond on the outside of the triangle, the exterior angle is always equal to the remote interior angles added together. So that is y is equal to 46 plus 58 and equals 104. So now I know this one. Now to solve z, I'd say, oh look, I know this angle and this angle, so I added 13 and 104 plus z equals 180. Subtracted, and I got z equals 63. Okay? I want to review one more time what an exterior angle looks like. Here's my triangle. This guy right over here would be an exterior angle. I could also draw one if I extended this line up here. This would be an exterior angle to here, or I could come down here and extend a line, and this would be an exterior angle. So all it is you're taking the lines of your triangle and extending one a little farther. Notice every time I do that, I create a linear pair with one of the angles, right? This one plus this one would have to equal 180. So there's different ways that I'm going to be able to solve those triangles when I have exterior angles. Okay? Let's take a look at a couple of problems that you might need to solve. Okay, I need to solve for x. Well, I don't know this angle right here, or do I? What do you suppose that angle would be? So some of this is going to involve you filling things in as you come around. I happen to see that that's a vertical angle with this angle. So I would write 100 right here. Okay? So I could say 167 plus x equals 180. Does that give me 13? Which makes x 13. Okay? There's another way I could have done it. I could have said that this 100, is that right, is an exterior angle, so it would have to equal these added together. Okay? So I could have worked it with exterior angles, I could have worked it with interior angles. This is what you're going to have to do. Now here's a very strange one. It doesn't have anything to do with that. We have no pictures, so stop for a minute, just look at this. The triangle's angles are proportional at 6, 8, and 4. Well, I'm just going to draw a triangle. What proportional at 6, 8, and 4 means is that they have some sort of multiplication of 6, 8, and 4. They aren't 6, 8, and 4, but they're related. So like if I said a number was twice as big, that would be a relationship of 2 and 1, right? This one is twice as big as this one. But I'll show you how to solve this without worrying heavily about the details. I see that the angles are 6, 8, and 4. So I would just write 6x plus 8x plus 4x equals 180. Okay? I put in the x because I know they're not really 6, 8, and 4 because 6 plus 8 plus 4 is 18. And how many degrees do I have in a triangle? 180. So I know they got multiplied by something. I just don't know what they got multiplied by. So when you get a problem that talks about this proportional idea, I want you to just put an x next to each one of them. Okay? So now I get 18x equals 180. So x must be equal to 10. Okay? If x equals 10, then I'm just going to multiply this by 10. 6 times x, 60. I'm going to multiply this angle here times 10, 80. And I'm going to multiply this one times 10, 40. And if I add 60 and 40 and 80, I will get my 180 degrees that I need. So, the trick to this, proportional, take these numbers out and put an x next to them, and then just use them the same way that you would use them in an equation. In this case, the equation was 3 angles added together equal 180. Okay? We'll have some more practice problems like this that you need to go through and make sure you're comfortable. If you can do these hard ones, you'll be good to go.